Hi everyone, my name is Zishan. Today we're going to be talking about something pretty fun, pretty, I would say, ambitious. Can AI really help us transform the entire software development lifecycle, or as you may hear me refer to it as SDLC? And I don't just mean can we get AI to write me a function? Can it get us to write a code? That's useful, don't get me wrong, but I'm talking about something a little bit bigger. Can we start with a small idea, a single sentence? Can we use AI to help us research it? Can we use it to understand it, to plan it, build it, test it, document it, and eventually even get it to production? And even more specifically, how do we use Rovo to do that? That's really where what we're going to be exploring. And later, we're actually going to put this to the test. So we'll start from a single small idea, no giant requirements documents, no perfectly groomed Jira ticket to get it started. Because let's be real, when feature requests come in, when bug reports come in, sometimes all we get is a single sentence. And sometimes we're lucky to even get that. So the question becomes, how do we go from that one sentence to putting something in production? So we'll go ahead and cover where delivery really slows down. But before we start throwing AI at everything, we really need to understand where the problems are, who's actually feeling them, and more importantly, why are these problems happening in the first place? And then we'll introduce Rovo and what we can leverage with Rovo. We'll take a look at teamwork graph, tool chain, connectors, etc., and how all of this really comes together to create that AI augmented lifecycle for SDLC. Then we'll put it through a live test, and finally we'll talk about some governance, and of course we'll have some time at the end for Q&A. So let's take a step back and take a look at, if we were to sit back and think, hey, where does AI really help us today? And in reality, a lot of us would say, well, the implementation part of it, right? Where we're coding, that's where it's helping us. But coding was never the hard part for developers. It was probably the easiest part of it. The hard part was planning it, right? Taking that small idea, planning it out, researching it, understanding what's available, what's not available, creating an architecture plan that actually will scale. That was the hard part. Once you have that done, writing the code wasn't the hard part. And then doing the testing, doing validation, doing deployment, and then maintenance is also there that we all need to do. You know, more than writing the code, reviewing the code was more painful, more harder. And then there's documenting. There's all these other aspects of what a developer is doing throughout that life cycle of taking an idea and putting it to production. So AI kind of fixed that implementation phase, but the rest of the area, well, there's nothing really there for it right now. So how do we really leverage it? And right now we see that, some of the core problems that people have is, well, just finding the information, doing that planning, doing that research, doing that feasibility analysis. So half the time we spend sometimes just gets spent on doing that research, finding that information before we actually get to the coding phase of it. And once we actually find that information, let's say it's from a different team and we need to communicate and we find that information, now we're about to start getting through. What we noticed was, well, even the teams that were using AI that started realizing that, hey, we're making a lot of new pull requests. We're getting a lot of output here. We're getting new changes introduced. But their developers are now also spending more time reviewing code. So the time that was saved by not having to write code just got moved into reviewing code. And as I mentioned, reviewing code is sometimes more complicated than writing the code. So at the end of the day, you might have more pull requests, but what's actually being shipped when the same amount of time is just being pushed over to reviewing instead of writing the code? And how can we optimize that? How can we get that fixed up as well? And at the end of the day, let's say it does produce that code. Let's say it does get deployed. Did we really have the confidence in it? And so if we look back and we start at the beginning, at the first phase of the life cycle where we start, let's imagine a feature request comes in. And sometimes the entire request is basically, hey, can we add this cool little thing idea? Or a bug report says, hey, this isn't working. Well, that's great, but it's not very helpful. And now someone has to go and figure that out. What are we trying to accomplish? What problems are we solving? What already exists? Do we have a solution for this already? Has another team already built this? And even more, trying to understand the user's perspective of what does this actually need to do? And a lot of the time, that first sprint, that first time that we spend on this is discovery as opposed to actually building it out. So we're researching, we're figuring things out, we're filling in the gaps. And that these gaps that should have been filled even before development sometimes end up being filled out afterwards. And the same thing happens with acceptance criteria. Sometimes they're incomplete, sometimes they're written after the development. And that makes the acceptance criteria kind of mute because they're supposed to tell you when your development is acceptable. But when we're writing acceptance criteria after the development has happened, well, those criteria are just telling you what you wrote. They're not really serving their purpose. And that's all even when they're created. Sometimes the acceptance criteria are never even written down. And all of this will just create rework, wasted capacity, slower delivery, and it just costs a lot. So instead of accepting that as part of the process, our goal is, can we make a fully formed unit of work before anyone writes even a little bit of code? And then we have another problem, which is the backlog problem. Well, the biggest issue isn't necessarily that the backlog is large. It's often that we have tickets in the backlog that are just underspecified. There was enough information to create the ticket, but there wasn't enough to actually build from it. So the ticket just sits there. And I would say about 6 months later, a year later, maybe 2 years later, somebody picks it up and asks, well, okay, what are we trying to build here? And so there's another problem. We don't always have enough information to understand why the decision was made to create that ticket in the first place. What problem were we trying to solve? 2 years later, who's going to remember that if it's not already in the issue? What was the original reasoning that the user had? Why did it matter? So even when you have the backlog item, we're often lost the context, or we've often lost that context that made that item useful. And once you have that ready and the code is built out, well, then there's still other things that we need to account for. And these problems don't disappear once development starts. Developers still have to compare implementations against acceptance criteria. We have to make sure that security checks pass. Quality issues can be discovered once the work is done. Then you have code review, and that depends on who's reviewing it. One engineer prefers one pattern, another one prefers another pattern. And now different parts of the same application solve the same problem in two different ways. And then we get to testing, right? There's a reason test-driven development exists. You take the acceptance criteria, you write the tests for them, you define what should happen, then you build the implementation that satisfies it. But here's the problem. What's the test based on if we didn't define our acceptance criteria properly? We're often writing these tests based on what we think the application should do. And sometimes based on what the code actually does already. We write the code and then we're like, hey, let's build out the test for this. Is that really the way we should be doing it? Because the test should come from the criteria. The criteria should come from the requirement, and the requirement should come from the actual business need from the user. What bug are we fixing? What problem are users encountering? What new feature are we introducing? That business need should define the requirement, which defines the acceptance criteria, which define the test, which define the code. And when any piece of that chain is missing or incomplete, everything down the chain gets worse. It gets weaker and weaker. So your pipeline fails. So what happens? We start searching, we start debugging, we start reading logs, we start looking at documentation, we start asking other engineers, we just try different things. Sometimes we'll just rerun the pipeline and then we'll rerun it again and a third time, hoping that third time's a charm. So we're waiting and we're fixing, and eventually, let's say we actually manage to fix it. And you get to eventually the feature work, you've tested it, you've deployed it. Great. Everyone celebrates. And then someone realizes or someone asks, well, what actually changed? Did we really update the documentation? Oh, yeah, that documentation, right? It's usually the last thing we do because we want to make sure all the changes are done so that we understand how to write the documentation. But that means that when deadlines get tight, guess what gets squeezed out? And even when we do write the documentation, we don't just need one piece of documentation. Developers need technical documentation. Users need release notes explaining what changed for them from their point of view. Because to a user, it doesn't matter if you introduce a new API. It doesn't matter if you introduce a new library, but developers, that does matter. So they need their own perspective. Users need their own change log. And stakeholders need their own reasoning as well. So they need their own documentation and change log. They need to know, well, what did you ship? Why did it ship? And what's actually the impact of shipping this feature or this new thing for the business? What does it actually do for us? It's the same change. There's not 10 different changes. It's the same code, same output, but now we have three different audiences. And in fact, there's a fourth audience, and that's the service desk team, right? So sometimes your support team says that, hey, we shipped the feature, but they're finding out from the customer calling them about it, like saying, hey, this isn't working. How do we do this? And so probably that's not the ideal strategy. They need their own change log so that they can say that, hey, here's a new feature introduced, so that when a customer starts contacting them about support, they have the troubleshooting guides they need to be able to provide support. So across the entire life cycle, we're basically having rework done, late defect discovery, you've got missing context, and unprepared support if we don't handle these things correctly. And these aren't theoretical problems. These are things that development organizations deal with on a daily basis. So you have to ask yourself, well, why should we use AI? And if you step back for a second, and if instead of asking, can we get AI to write more code for us? What if we sit back and ask, well, what is AI actually really good at? And one of the things is well processing information and understanding context and transforming context. So we have an enormous amount of data and we get more and more tools added every day. You've got Jira issues, you've got Confluence pages, you got code, you got documentation, support tickets, requirements, you got logs to process, pull requests, and on and on. And that's just from basic tools. And you might have more and more tools that you need to review and process. And so we have a hard time processing all of that information. That's where AI can jump. It can process that. It can connect that. It can summarize it, it can transform it for us, and it can even identify patterns and it can turn one form into another, right? It can take a Jira issue and turn it into code. And that's really what we're trying to do here is trying to see where we can leverage these functionalities of AI in different parts of the life cycle. So we're trying to use it in the entire software development lifecycle so that we can actually spend time making the decisions as opposed to actually doing the research and building things. And so once you get an understanding of why we're using AI, let's take a look at why should we use Rovo? So Rovo has a really strong foundation. It's called a teamwork graph. And whether you use Rovo search, chat, or agents, or whatever you're using, you're going to connect to this teamwork graph. And so if you ask yourself, well, what are we trying to access there, right? All that knowledge, that company knowledge that we have, whether they're in Jira issues, whether they're on Confluence pages, repos, pull requests, you've got documentation on Notion, or you've got code in GitHub or GitLab. All of those things now need to be accessible to the person doing the research, doing the code. So all of that needs to be accessible. whether they're external systems or their internal systems. And so the teamwork graph gives Rovo this connected data layer across all of these different sources that gets indexed into one piece, one graph of work. And that's an important distinction between other tools because we're not just caring about individual pieces, we care about the relationship between them. That Jira issue is related to that project, and that project is related to this documentation. That is related to this repository, etc. And who worked on this? Who do we need to contact when we need to ask something about this? All of that context is what we need to leverage. And more importantly than all of that is our permissions. And this is what makes Rovo great to use. It takes into account the user's permissions. You see, Rovo doesn't give me access to everything in the company simply because I'm using AI. Rovo has access to it. But if my account can access a document, Rovo can use that document when helping me. But if I can't access that document, if my user account can't access it, well, Rovo doesn't suddenly just give me access to it. And so the AI will operate within these boundaries of permissions that we're going to set up. So there's going to be a boundary where the AI has permission to access it, and then another boundary behind it saying, well, do I have permission to access it? My user account that's interacting with this AI account. So even if the AI can access it, it may be possible that I'm not allowed to access it. And so it's going to need to take into account both of these, no matter if we're going to use search or chat or agents, wherever we're using them. Whatever we're using, it takes into account all of that permission. And that's very critical because that's what makes it viable at enterprise scale. Now, I mentioned a couple of these already, and at the simplest level, Rovo gives you AI functionality, AI capabilities that's built right into the Atlassian ecosystem. And if you're already using Jira, if you're already using Confluence, well, that's kind of important because that makes things a lot easier for you. Because instead of starting with an AI that knows nothing about you or your company or how your organization works, you can start connecting all the context when your work is already happening in those places. So with Rovo Search, for example, it allows you to search across the Atlassian connected sources and even external sources that you connect to it. So by default, you'll have Confluence and Jira, but through other connectors, some that will come out of the box, some that are native, and some that you will add on through external sources. And so you can have external tools like Google Drive or GitHub or GitLab and other systems connected to it. But instead of relying on keyword searches, we're using natural language. And Rovo helps us really surface, well, the most likely result with the right information, as well as giving us, hey, here's all the other related info that you may need as well. And then we have Rovo Chat. And so what Rovo Chat is, it's going to take that search layer and say, well, now I'm going to give it to you in a conversational interface. So you can talk to it. So once it finds that information, then you can start doing something with it. And now you can start transforming that context of that information to something else. You can find these related issues to this. You can get it to summarize them. You can get it to compare them, turn them into requirements, create a different ticket. So you're taking knowledge that you're finding across the company and you're leveraging that and saying, let's turn it into something else. And then you have Studio and agents. And so Studio is where you're going to manage all these agents, where they'll get built out and controlled and configured. And these agents are going to become incredibly useful in this SDLC that we're building because we're going to create, or we've actually created about, I would say, 20 or so specialized agents because we don't generally want one giant agent trying to be everything. We don't want it to be a product manager. We don't want it to be an architect, a developer, a security reviewer, a QA engineer, a technical writer, support specialist, and doing this all at the same time. So you have to think of it like having 20 different employees who are each trained to do one specific job extremely well. So each one of these agents are trained to do that specific job extremely well. So one agent does the research, another one does the feasibility, another one does the architecture, another one for the acceptance criteria, security, documentation, pipeline troubleshooting. All of these different things fall into play with different agents. And instead of one agent trying to do everything, you create an agent to agent workflow that allows context to move from one agent to the next. Now, once you understand how to use it and you understand that there's a layer of saying we can connect data to these interfaces, whether search or agents or chat, well, where does this data come from? And so, like I said, there some might be connectors that are built in and native to it, like Bitbucket, Confluence, Jira. They'll come built into it, but there are also out-of-the-box connectors that already pre-exist that you can just use. And if you can't find any out of the box even, you can actually create custom connectors. And there are a couple of different types of connectors. And the main ones we're going to be talking about in the SDLC are the synced connector and the direct connector. So these connectors are how we are going to leverage that information for Rovo, which is going to be accessed through the teamwork graph, all keeping in mind our permissions. So with a synced connector, information from an external resource can be indexed and made available. And all of this is set up by an admin. They're going to configure it, and then all that information gets indexed. And so when we're using Rovo, it already has access to that information. It already has access to those permissions, and we can just pull in and say, hey, what XYZ, and it finds that information for us. The direct connectors are a little bit differently, but they work pretty much the same way. So instead of indexing the information beforehand, Rovo will just make those queries live when we need it. So if we're accessing something like Gmail, for example, Rovo can make that request using my permissions, retrieve what it needs from Gmail, and use that information without indexing the entire source of our email directories. And then you have smart links. So smart links are a little less important for the SDLC lifecycle, but they're really useful because let's say you have a link from GitHub or you have another external resource and you have a smart link connector for it. When you paste it into, let's say, a Confluence page or into a Jira ticket, etc., you'll get a nice little embedded representation with really cool metadata, as opposed to this long, ugly URL. And if Atlassian doesn't provide the connector you need, you can create your own. Think about it. Sometimes in our use cases, we built internal applications to manage different things across, whatever we need for each specific organization. Sometimes these tools are being built over 10, 15 years. Every time we need something different, they get updated. And so we have this tool living here for 15 years and no other company uses, but everybody internally depends on it. Like, for example, if you have a tool that's, going to tell you which employees are on vacation, which are available, which are online and working and ready for new work. So when these tickets are being created, we're going to go into that and say, here's an engineer. We're looking for a backend engineer who's available right now to work on this ticket. And so we can plan that out accordingly. Who's going to be available, let's say in October, for example. And we plan that out. And we're all aware of this tool. We all use it, but we're kind of afraid of it because nobody wants to touch it. And so as long as we can expose that tool to Rovo using a custom connector, we can bring that knowledge over into Rovo. Well, now it becomes really easy to use and no one is afraid of it because all of that hard part is taken care of. And that's important because in enterprise environments, well, they are messy. And so our AI strategy has to work with that reality in mind. Now, sometimes you may even need to access this information from outside of Rovo. And there's another interesting piece here. What happens when you're not actually in Jira? What happens when you're not actually in Confluence? Maybe you're working in ChatGPT. Maybe you're working in Claude. And When you're there, you still want to be able to access the information that Rovo has access to. So you use the Rovo MCP server with these tools, and now it's functioning the exact same way, but there's a slight difference. So you see, the MCP server only kind of changes where the request originates from. It doesn't change who's allowed to see it. So the permission stuff still stays baked in. So even though the MCP server exposes it, it exposes it by keeping in mind who has permission and who doesn't. So just because you're using ChatGPT instead of, Rovo and Jira, well, that doesn't mean you can suddenly access information that you couldn't access before. The permissions don't change. The only thing that changes is where that request originated from. Did it originate from Rovo within Jira or did it originate from ChatGPT, for example? And that distinction is really important, especially when we're thinking about security and enterprise adoption. And the same thing holds true for the Teamwork Graph CLI. Whether you're using VS Code, whether you're using Cursor, whether you're using Claude Code, Codex, whatever you're using, these tools can leverage CLI tools. And so with this CLI, you can actually make these tools start accessing this data and even sometimes a little bit more than the MCP server because it provides a little bit more of a broader coverage. But now these tools can actually just get that information right from the CLI as it's doing these things. So it can execute these scripts, find that information it needs. So you have coding standards, you have coding guidelines in Confluence, let's say. It can pull that information when it's trying to make an architectural plan to be able to say, hey, I need to make this work. And you can do that all through Cursor. You don't have to be in Jira. You don't have to be in Confluence. All of that gets plugged in there. And like I was saying before, well, when we start giving access to all of our organizational data, something should start sounding an alarm bell in your head. The first thing is, well, is it actually secure? Because what you're really saying is we're going to connect AI to all of our company's information. And if you were to be on a call, on a company-wide call, and you said that, that would be a fantastic way to make your security team suddenly wake up in the meeting. The important thing is that Rovo runs on Atlassian's platform, and that platform inherits that underlying security model. We have that permission enforcement, data controls, audit and threat detection. You have these things that Atlassian already provided out of the box for us. These protections around how customer data is handled are there. So we're not starting from here's an AI tool, good luck with it, here's all our data. You're actually starting by saying, hey, well, we have this security foundation built by Atlassian for its tools, provided by its platform, and then we're adding our own governance on top of it. And that's what makes the difference between a cool AI experiment and something you can actually consider scaling across an enterprise. So if you start saying, you know, let's start figuring out how do we actually implement this in our SDLC. So just to understand, you now have understood what Rovo is. You've understood why we're going to use AI, and you're going to understand where to use it. And so this is where we're breaking down the life cycle as defined by Atlassian into these phases. You have the planning phase, you have the feasibility phase, the system design, the implementation phase, you have the testing phase, the deployment phase, and then the maintenance phase. And each phase of here has a different problem to solve, which means each phase needs different AI capabilities, different AI agents, different contexts, and potentially different specialized agents. Some of these agents may work across multiple of these phases, and that's okay. Others may have one very specific job and only serve that specific purpose, which is also okay. But together, when you create that agent to agent workflow and you can make it pass through this entire life cycle, that's where context can move forward. And we're going to start where every project starts, planning. So when an idea comes in, sometimes, hopefully, it's detailed. You know what you're building. But sometimes it's just a single sentence, sometimes even barely that. So you have to ask yourself, can AI really understand enough about this idea to help us decide what we need to build. Before we even figure out how to build it, before we can ask, can the AI build this? You have to ask, well, can it understand my needs for what I'm asking for? Can it understand if we have all this information available to us and leverage that information to decide how to build it? Then we actually get to the building phase. And we have, thanks to Atlassian, we have this platform where we have all of these native tools available to us. So we have Rovo Search, Chat, etc. We have these built into the ecosystem. But Atlassian provided an extensible platform. And this platform gave us the ability to use Studio to control agents, to create them, to manage them, configure them. Same with the Forge applications. We have the MCP server. We have our Teamwork Graph CLI. We have all of these tools which we leverage to create what we see on the bottom here, which is everything that we've built out to serve for that entirety of the software development lifecycle. And so whether we're building out the feature initiator tool, or we're doing the researcher agent, or we're doing the blocker checker agent, the optimizer agent, whatever it is that we're using, it's only possible because of that platform that's made to be extensible. So we can leverage Rovo and we can leverage AI throughout this life cycle because we can pick and choose how we apply this AI tool in these different phases. Now, let's go ahead and actually see that in action. So we're going to look at how we'll take one simple idea without any giant specification of what's actually needed, right? A real simple use case, and see how that actually comes into fruition and get it to go through an entire research, get it to be understood, challenge it, turn it into a fully formed unit of work before anyone even writes code. And then when the code is written, well, how do you move from reviews to deployment to maintenance? And so we'll go through that now. Okay, so if I switch over here, we can actually see we have Rovo Search open up here under Confluence. So if I just reset this, you can see that when you open up Confluence, you get Rovo Search built into it. And it's not just keyword searches anymore. It's actually something that you can use using natural language. So as an example I had here earlier, how can I make an invoice with with the Aquila Pay product? And so instead of it just giving you using keyword searches about, hey, we're looking for invoices, and you can find all these different documents and resources that's connected to it that might be related to this. Instead of just using keyword search, it's going to use natural language to kind of say, hey, I'm going to figure out from all this document and all this information, what is the user actually trying to get at? And so what we're actually trying to get at is how we make an invoice using this product. And so it goes in and says, hey, I'm going to figure this out. I'm going to provide the solution. And it's right there put in front of us exactly what we're looking for. Now, all of these other things are also made available for us if we want to jump into those specific pages or those specific documents. And even that can be fine-tuned. So we can kind of say that, hey, I'm only looking for Confluence related stuff. I don't want you showing me anything else outside of this. Or you can say I'm looking for GitHub stuff. Or depending on what connectors we have on this, you can enable searches for that specific connector to find that information really, really quickly. And then based on the connector you're using, you'll have different options of, filtering out that to make it even better and better for the search to give you exactly what you're looking for. Because the faster you can find something, the better you can find something, the more likely the rest of the chain will succeed successfully. So now, once you have the search done, if we just open this up, we have here this Rovo Chat button where we can say, hey, can we do that same thing? How can how do I make an invoice with the Aquila Pay product? So whereas we did this with our search interface, now we'll do it using our chat interface. And so with Rovo Chat, you have the same kind of functionality where it'll go behind the scenes using your natural language search and try to understand what you're looking for, find what you're looking for, and give you the response that you're looking for. But now it's in an interface where I can tell it to do something with this. So I don't have to stop here. I can actually say, hey, you know what? Let's open up a ticket with this on how to implement this in our automation so we don't have to manually do this anymore. So we can continue this using the data that it found. And you can actually see it's already recommending options for us to act upon. So with the chat interface, you have the ability to leverage all the power of Rovo Search, but now you can push it further and say, well, let's start taking actions and transforming this information that we found into things that we can now use for other purposes. And so if you need to do that, this is where the chat interface really shines. And even more importantly, what we're actually using here is the default Rovo agent. And if you wanted, you could actually use different agents here depending on the use case of what you're looking for or what you're trying to do and what tools or skills that those agents have, and those can be applied as well. Now, when you're actually configuring and setting up these agents, that's where this studio will shine. And so if we just open up our studio, you can see one of these agents I've already loaded up where we use this agent to actually optimize our descriptions. So as an example, we'll have here, we'll tell it how to write the acceptance criteria. So when tickets are being created, it will go in and say, hey, is this there? Is our acceptance criteria there? This is how we're going to expect the acceptance criteria. And it'll look through all our sources to say, how to determine what acceptance criteria need to be there. It'll look for any defensive edge cases, any implementation notes, and anything that we would probably want on the ticket. We will have it built out so that we never have this issue again of saying, well, we have a backlog full of tickets. We don't know what we were actually trying to do. Now, not only do you have that system prompt there telling this specific agent how to function, we also have different functionalities that we can introduce to this agent. So we have skills, tools, knowledge, reasoning, conversation, and web search. With we'll start with tools, as tools is one of the most lowest level of functionality we can give to the agent. So the tool is like a very simple purpose tool that we're going to give it. Get me a Jira issue, get me a Confluence page, or trigger a function on AWS Lambda to do something that we need to do. That one specific functionality, that's what that tool call is for. And so you can connect MCP servers here so that you can enable all these different tools. So all your robo agents can now use different products, whether it's GitHub, whether it's Sentry, whatever MCP server you would like to enable, you just bring them in and now you can enable them. And once you have all this set up, well, then you can start looking into skills saying, well, I have a tool that can get me a Jira issue. I have one that can update one. I have one that can do other things to it for Confluence, to AWS, to other things. But how do I train the AI agent to use multiple tools together to accomplish something? And that's where skills will shine. So now we can basically get the agent to kind of understand that, hey, I don't just want you to use this one tool to do this. I want you to use this tool in this order, then use this tool, then this tool, or do this and then format it, and then the final tool, and then give me this final result. That's the skill, right? So you can combine it and train it on saying, hey, take advantage of all these different things and then do this final thing that I'm going to need for you to return. So that's where the skills really shine. It's putting together all those different tools. Then comes the knowledge. So the knowledge is basically how these robo agents are going to work and how well and consistently they're going to work, because this is what's going to give them knowledge. So even if Rovo generically has access to said knowledge, even though it has access to Jira or Confluence, our agents might not have that knowledge. So when we create this agent, it might not have any organizational knowledge at all. But when it doesn't have any organizational knowledge, what's actually happening is, well, Rovo has permissions to access it. My agent doesn't have permission to access it, but I may have permission to access it. So if I try to use this agent to access something that Rovo has access to, well, it's not going to because it's failing this checkpoint. Because this agent doesn't have access to it, therefore, even if I'm using it with my permissions, it's not going to be able to access it. So you have to pass all these checkpoints in order to be able to pass that permissions layer. Now, with custom knowledge, or before custom knowledge, if you just give it all organizational knowledge, the simplest thing, but sometimes you don't necessarily want to give it all that knowledge for that specific agent. But all organizational knowledge would give it access to everything that's built in natively, Jira, Confluence, etc. But it would also give it access to any of the external connector tools that you enable it with. And so if you have GitHub connected, well, now it has access to all your GitHub, but does it really need that information? So if we just kind of pick custom, well, then we can fine tune, say, hey, we only want this specific agent to have access to, let's say, Confluence or Jira. And if you have other connectors, they would display down here as well. And even more so, you can actually fine tune saying, hey, I'm giving you Confluence access, but I only want to give you access to, these specific spaces. And so now there's another permission layer on top of it saying, okay, well, Rovo has access to Confluence. This agent has access to Confluence, but it only has access to these two specific spaces. Therefore, when I'm trying to make a request, if this agent doesn't have access to the space that I need, well, it's not going to be able to help me. It'll only be able to access these specific spaces. And more importantly, if my account doesn't have access, but the Rovo agent does have access, it's still not going to be able to access it. It will only access if my permissions are approved for this space, this agent is approved for this space, and then finally Rovo itself has access to that space or to that data from that connector. And so all of this needs to get passed through that permission layer for it to actually say, okay, well, now I know what to do. I can get that information. And so that's our custom knowledge behavior. Oh, I think I forgot to click add. And there you can see how it'll look. So in our case, we don't actually need this. Let's just go ahead and say, you know what, let's keep it simple for now. Let's just give you both content and space. And now, just to save a little bit of time for the rest of the demo, basically, sub-agents are going to be another way for us to kind of configure these agents. So we can create an agent, but then give it access to different sub-agents that it can trigger and run and execute based on certain triggers. If I provide you a ticket that has this in the description, well, then trigger this sub agent to get this approval. And that sub agent can have its own tools and its own skills in order for it to do its job specifically with its own knowledge base. And when that comes back, well, now you can say, okay, well, the main agent will get that response and decide how to act upon that response. Now, all of this is done through Studio. Studio will also allow you to manage your applications, your automations, etc. And all of that is available through Studio. So this is just one agent that we're actually managing, but you can actually manage all of your different agents through the Studio as well. And so like I said, we have about 20 different agents in the chain. And that's just for SDLC. Now, when we're actually trying to say, okay, well, how do we actually look at that demo, right? So we have some idea that we want to take from a very simple idea to something that changes the production running code. And so if you imagine yourself having, some software running, some application is running already for you guys, and it would look like, let's say some, e-commerce website, then how do we take it from there? And if a user sends a feedback and says, hey, you know what? I wish this had a wish list. Sometimes I can't, buy it immediately, but I want to add it to a wish list so that I can buy it or I can share it with somebody who can help me buy it, etc. And so with that little bit of an idea, how do we go from that to creating something like this, where, for example, if I click on the product page, I can add something to my wish list and then thereby going and seeing, hey, well, that's on my wish list now. Now, in order to do all of this, we'd actually be seeing, or actually, we'd actually be starting off from just a very basic idea. So as an example, here we're on Jira on a product page here, or sorry, on a project page here. And we're running this feature initiator tool where we're basically say, well, you know what? This tool is connected to our JPD board. And on our JPD board, we have all these tickets laid out for different ideas or different stuff. And you can configure this to be, if it's not JPD, maybe you will have a different backlog on a different project or a different space. And so we can just connect to that. Now, once you actually connect to it, and say, hey, let's go ahead and use this wish list idea. It'll pull in, and here you can see it's a very simple idea, nothing too long, nothing too fancy. And then we'll say, okay, let's go ahead and submit this. Now, the rest of this process can take a really long time depending on the complexity of this request. Now, this one is relatively simple, but still, in order to do something like this, we need to kind of figure out a lot of things and it needs to do a lot of research behind the scenes. So this can take about, 20, 30, 40 minutes to see it go from just analyzing it to doing the feasibility analysis to making sure it has all the information it needs, what to edit, what code to edit, and making sure we're following the frameworks and the standards that we've set for it. Once it actually does all that, then we can actually jump into saying, okay, well, now it has some research and it'll produce something. So once it actually finishes doing the research after about 20 or 30 minutes, then it starts saying, let's produce a research document. We'll get it passed over to a plan of action, and et cetera. But all of this research needs to be done so that our chain can flow properly, right? So we have this small idea. We need to elaborate it. We need to figure out what is the user really trying to solve here. So if I jump over to this research page, which we actually created a little bit earlier today, just so I'd have it ready, because this is probably going to take, 20, 30, 40 minutes to do. But with this, we've done basically that entire process of saying, hey, I have my entire wish list research here completed. So I've got all of this information that this Rovo agent has produced. And we've gone through all of this, but in reality, sometimes it might be something that a user is willing to sit there and read, but sometimes nobody's going to sit there and read a 30-minute page long document for every single change that we're going to be making. Sometimes it's doable. And but in that case, that's where we introduce an agent called a plan of action agent, which will basically take that research that we built out and turn it into an actionable plan and say, well, here's something that we're going to lay out. Here's what I'm going to edit. Here's what I'm going to be doing. I'm making this page. I'm doing this on the cards that are making a real plan that a human can go into it and say, okay, well, let's go ahead and review it. So as it goes through this, it'll actually pause and say, hey, I've got the plan of action ready. Do you want to go review it? And then click approve or retry or reject, etc. But once you have that plan of action and then you click approve, then it proceeds and says, okay, well, let's start actually turning that plan into tickets. So in this case, because it's a relatively simple request, it creates a simple epic. And then inside of that epic, it'll say, let's create these, tickets that we're going to need to build upon it. And so if we just open up this ticket, for example, oh, I think I already had it open, but if we just open up that ticket, now we can see what this ticket was actually created by this agent. And so it's actually created a ticket, laid out its parent-child relationship. If it needs to create multiple epics or multiple different issue types, all of that is just defined in the settings of how we configure it. But once it all goes through and it gets created, well, then now it just has to decide on passing it to the next agent in the chain that says, okay, well, now let's go ahead and create an ideal description, taking into account the acceptance criteria that we're going to be looking at, the defensive edge cases, the implementation notes, everything that we basically wanted in order to build out that ideal description in order for us as developers to be able to review this later and act upon this later, but also when we pass this to the next agent in the chain, our Rovo dev agents, those agents can now actually start implementing this way more consistently because now it has everything it needs to write the test. It has the defensive cases that it needs to count for, everything that it needs. And after the description optimizer agents run, then you have other agents meant for whether it's, generating the solution. So for example, it'll come up with a high level architectural solution saying, here's what we're going to need to do, and here's the files we're going to change, here's how we're going to implement it, etc. All of that is going to be built out. And then we're also going to have a agent that's going to be checking for blockers. So sometimes it's very easy to find other blockers and connect them, but sometimes we miss them, right? Those tickets don't exist. And so this agent is also looking for logical blockers. For example, let's say you want to add a navigation bar or a button or something. Well, before you can add that button, before you can add that landing page, before you can add that nav bar, you want to know how to design it, right? Well, what logo should we be putting there? What image should we be putting there? What fonts? What colors? Should the logo be on the left side or the middle, etc.? All these different choices need to be made. And so it can look for logical blockers and recommend blockers that say, hey, this should probably be a blocker if it isn't open. And then finally, once it's ready, then you can move on to actually building out the code. And like I said in the start, right, building out the code was never the hard part, right? Our agents can build it out. And once it goes through and builds it out, you get a pull request like something like this created by Rovo Dev. So this can actually be done right within Jira. When you open up that ticket, it can also start writing the code right there for you. So you don't even have to open the code editor. But Rovo Dev also works in code editors and tools, so you can also use it there as well. Now, once it actually produces this code, you'll actually see it'll create tests for us. It'll create the actual API logic, the backend logic, the front end logic. It'll even show us like, hey, this is what it decided on creating for that navigation bar. This is all the functionality that it produced. And then, as I mentioned, we also have the tests for it, whether that's going to be unit tests or integration end to end, whatever it is that we have in our guidelines, it'll go through and create those as well for us. And then once you actually have your commit ready on a branch, then we can open up the pull request, and the pull request will trigger and say, hey, you know what? I have here the Rovo dev agent for the code reviewer that's going to come in and say, where are your acceptance criteria for this ticket? And let me compare them, right? Did you actually meet all the acceptance criteria? Here are the ones you've done. Great. Here are the ones that have not been met for this specific uh, pull request. So we need to go back and finish this. It'll also look for your code and suggest changes saying, hey, you probably shouldn't write it this way. This could be a security issue. Let's leave it like this. Let's change it to this style, etc. Now, with code review done, then you end up saying, okay, well, once we've merged this, or actually before we merge this, or if we merge this, we also jump into our pipelines. And so we created this pipeline, a very simple pipeline, but we created it just to be intentionally failing. So we can kind of look at this pipeline troubleshooter that Atlassian provides, which is really, really cool that RoboDev will come in and say, hey, you know what? I'll look into this so you don't have to see the errors. You don't have to figure it out. We'll build it out and we'll fix it and we'll say, here's a human readable way of understanding what the cause is and how to fix that problem. And so that way, you're not looking at these massive errors or hunting down log files. You're just looking at this cool little summary saying, here's the cause and here's what you can do to fix it. And then once you've deployed it, well, then you get into change logs and producing them. All that documentation is done. And then you also get into the next life cycle or next phase of the life cycle, which is about the maintenance side of things. And so I have a couple of tickets here where we have tickets showing a couple of different agents. We have the ticket severity assessor, but here's an example of one that, our possible solution searcher. And what this really does is there's about 3 or 4 different agents that go together to produce this output here. And whenever a ticket is open, some user recommends a bug or something's not working or a new feature. What these agents will do is they'll come in and say, hey, let's look at all the different issues that we have. What are similar to this specific request or this ticket? Find that information, put them, rank them according to similarity, and figure out one, let's put that information there. And two, can we find a solution that we can recommend to the user saying, here's what will most likely solve it based on the solutions that others have had that have resolved their issue. And then we have another agent or another agent in the system that basically looks at the tone of conversations between support agents and users as they're coming back and forth conversations, trying to solve these problems for users. But sometimes a user can get frustrated or they can get, they're not getting the help they need, or maybe now they are getting the help what they need and we need to adjust that. So this ticket or this ticket escalator agent is actually going in and looking into the labels of saying, hey, you know what? I'm going to change this. And I'm going to say, hey, as I'm talking through this, and the user and the and the agent, or sorry, the support agent is talking to another, it will detect the tone and pick up and say, hey, you know what? I'm going to edit these labels so that there's no risk or there's a severity risk, or I need to assign it saying, hey, we need to escalate this. So we can take different actions by detecting the tone of the user before something gets, out of hand, and we can pick up on that even before. So we implement AI throughout all the phases of the software development lifecycle. And if we quickly just jump back in to the slides here. Now, for governance, it's really important to understand that all of this looks really cool. It sounds really cool, but at an enterprise grade level, you don't just want to throw AI at it. You need to make sure you have a governance framework there. You need to make sure that you have something ready to go so that you can start implementing it with, security and safety in mind. And so our framework here basically takes advantage of the tools that you're already using, and it'll come built into it. So you don't have to have new tools, and it'll provide you things for different use cases, for different, usage visibility, for policy exceptions, for risk, review cadence, and even configurations. And all of this information will be available to you using the templates that we have. So it's really lightweight to get started. And so if you're looking to get started with Rovo, or if you're already getting started, but you want to make it scalable for your company, then this, half-day discovery workshop that we have is probably the best way to get going. And so if you ever, if you're interested, yeah, feel free to reach out to me or reach out to Robert, and I'll pass on the message to Robert. But basically, if you can kind of find a way to say we're interested in Rovo, but we want to make it ready for our enterprise needs, how do we do that? Well, this is where we come into play, and we provide that governance framework. We provide those workshops so that you can actually get up and going, so that you're going with safety and security in mind with that framework. And so it doesn't matter where you are, whether you're just starting to use Rovo, or if you haven't even heard Rovo and you're starting, or if you've started using Rovo and you started implementing it, but you're trying to scale it. Or if you've already got it working on a team, now you're trying to get multiple teams on it and you're trying to get multiple users using Rovo. Wherever you are in this journey, that framework can come in and play. Wherever you are, we can kind of jump in and help out wherever you need. And so whether it's the framework, whether it's, SDLC or any other category of tools that you would want to leverage, that's where we jump into that journey. And as I mentioned, my name is Zishan. If you guys have any questions, please feel free to leave them in the chat. I'll be watching them now. So if any questions, please send them through. And if you need anything, like I said, feel free to stay on in the Q&A, and I'll be here for a couple of minutes as well if you need.